Nobody is scared of them. Even aquatic expert, they always talk on the fish, but they never talk on this wildlife. The wildlife is so we all know how much important the rights are. And many things have been harvested from the wild species, but in Nepal, all the experts have migrated. And we have targeted now within this aquaculture land, we also consider wildlife, cornice, and this is the we call land masses. It always grow even if water depth is off, increasing. This is a typical land mass we call batty land masses. It's almost lost, but we conserve them in the aquaculture lands. This is our Nepal agricultural land stations, and our plan is to establish the aquaculture lands in all land stations. So far we have only 5. But our target is to establish in all the stations having these features that I already showed. These are the native fish species that we are targeting. Because aquaculture can be established in all areas, either it's in situ or ex situ or on farm. We have followed 3 strategies: on farm, ex situ, and in situ. In all conditions, we can have an aquaculture land. This is the typical analysis of the fish that we can conserve. The term variety analysis might not be acceptable to the fish expert, but we can discuss on that with terms. I asked many fish experts after the taxon below the species, what is the right term? But I could not see. Then we initiated, because in Nepali, for everywhere, for every genotypes, we call jat, masako jat. That's why we use the terms variety and land masses below the species taxon for our conservation perspective. And we also initiated we call community aquaculture. You know we have many ponds in the public area. The community forest in Nepal is very good example to the whole community. They have a good contribution in conserving the forest biodiversity. In the same principle of community forestry, why we should not start having the community aquaculture? This is the main thought and main guiding principle that we are working on, conserving the aquatic resources, mobilizing the community. This is recently established in Kapilvastu, targeting wildlife. There are large areas and associated with other species because the fish we define, fish is the eco-friends of wildlife. That's why under the aquatic pond of wildlife, the fish we can include for conservation. I mean, this is in Gawa Valley, in Baki, and we have in Palpa, there is one public pond. Almost is now demolished because of establishing the medical university, medical hospital. There is a big debate as well. Even we can see some issue in the newspaper, and we thought let's have the public communities in that. The mayor agreed, but it's still not going smoothly. We have to interact many times. And another approach, because each household in Nepal is typical compared to other countries. Each household in Nepal conserve and continue growing the 6 components of biodiversity. That's why one of the components is household aquaculture. And the same concept we actually do in school area. We have circulated even education ministry to mainstream the aquaculture in school. We call school aquaculture, mobilizing the students. They have a space, they have a student. The student is for not only textbook learner, they are practitioner. And each student's house, they might have some aquatic species. Just ask the students to bring at least one species of aquatic and then keep in the pond. This is a very simple technique and very effective. And they provide learning materials, conserve, improve environment, and then economically they can harvest. And another approach, this is a very also excellent approach because you see in Nepal we have many ponds near to the temple. Temple area we define is religiously and automatically protected. That's why we started. We can see in Nepal I think you all have experience why we should not define this as a religion space as acquisition sanctuary. Here our target is let them the domesticated species. After domesticating the species, we never allow them to grow in the nature. That's why they never become the competent in the world. Because we know everything is keep changing. Morning, day, that's why the climate is keep changing. But our population that depends with that on where we depend, we never allow them to evolve themselves. Even we never now respect the meiosis event. Because meiosis is the major one that helps to develop the new genotype. We believe after developing the new genotype, they become the competent compared to other pure line. Even we change the policy, Nepal government always adopt the uniform and even the single genotype in the large area. Last few years we revised the policy and now the evolutionary populations can register formally by the community. This is the principle and new area and many global communities they are interested. In national park, we have a national park. These are the for wild species. But most of the endangered species are agriculture related. But we don't have such park. And we ask our government and we also give the written document. Let's define the agriculture sanctuary in as many as possible in Nepal. And then all the domesticated species we can grow there. We can keep or conserve there. And this will be the resource center, the gene pool center. The researchers can have a look and select the materials that what they want. This will be the very effective. And this is our national park. And we are also having the discussion with the personnel of the national park. Why we could not define, we visited some national park, and they are agreed, and they are even also agreed to have our technical orientation sessions, how we can establish the aquaculture in the national park. If it will happen, then it will be the milestone for conserving the aquatic resources in situ. And also we know we have a wetland, but nobody is there talking on conserving the aquatic resources through this principle. That's why we also having the talk. This is not material life, but we are having a talk. I will share some senior to help to accelerate this process. And these are some accelerators. We have defined the conservation tools, and the second is conservation accelerator. That means any activity that helps to conserve continuously. But the main purpose is different than conservation. But if you conduct this activity, it conserves automatically. For example, stock improvement, restocking, domestication, and these are some we have a legal provision as well. This also are helping to conserve the resources in Nepal. And these are some species that we restore.
Please try to sum up here.
I think are some species we are controlling.
Exposure. There are 528 genes that was upregulated and 488 genes was downregulated. So in this figure, we can see that the blue color represents downregulated and white color represents the upregulated. So based on these results, we got some basic results. We just know the number of differential expression genes, but the further results we want to know. So we perform the key pathway analysis for the bioinformations. So in this figure, I want to show that as I mentioned before, the target genes of microRNA was the important part of this research. So we also identified the target genes of the microRNAs and the differential genes of transcriptome was combined to common genes for KGG analysis. So these common genes should be have two factors. Number one, it should be the target genes of microRNAs, and number two, it should be the differential expression genes in transcriptome. And from that, the KGG analysis shows that the drug metabolism cytochrome P450 and the metabolism of axonobactics cytochrome P450 pathways was significantly enriched. So in this figure, I'm not sure if it's clear. So in this way, you can see that this is the key pathways. And the figure shows the key analysis of differential genes. The top enriched pathways are the steroid disease and chemical, the DNA attacks and metabolism axonobactics by cytochrome P450 drug metabolism cytochrome P450 pathway. So that is the key pathways in this research we have found. So through these key pathway analysis, we also construct the network between the microRNAs and the TAPI genes and the differential expression genes in transport. And through the KPG analysis, so we can see there are two common genes was imaged the pathways of cytochrome P450, and in this network, the microRNA 1468 and microRNA 1213 has an active regulation to these two TAPI genes, these two differential genes. So because as I mentioned before, the TAPI genes was the important part, and microRNA was involved biological process by regulating the TAPI genes. So that's what shows the potential mechanism. So to verify the results of sequencing, if it's reliable, so we also performed the qPCR analysis to detect the expression genes, the expression of the genes. So we randomly chose 5 microRNAs and 5 differential genes. 5 differential expression genes to detect their expression. So according to these results, we can see that some of these all was reliable, was consistent with the sequencing of the microRNA and the transcriptome. So according to our above results, we have to construct a mechanism that the pathway of the biotransformation of geosmin. So as at the beginning, we want to know the effect and response strategy of the geosmin in the grass carpet liver. So this is the potential metabolism. Okay, got it. So these have some results. Geosmin is metabolized by the cytochrome P450, and the form of geosmin was metabolized by UDPGE. So this is the key enzymes, and geosmin was metabolized by directly UDPGE, and microRNA involve metabolism process of the geosmin by regulating the TAPI genes. So this is the conclusion of my research. So geosmin presents the genotoxic and cytotoxic to grass and cytochrome P450 and UDPGA plays an essential roles in biotransformation of geosmin. And microRNA involved the biotransformation of geosmin through downregulating the TAPI genes. And the way the geosmin entering the fish body should be paid more attention. So our research result was published on the journal Ecotoxicology and Environmentality. So the first one. So if you want to contact with us, you can connect with me or the corresponding author, Prof. Liu Liping from Shanghai University. So that is our results. And I want to give some acknowledgement. The travel of research fund for this presentation was provided by the China Asia Belt and Road Drugs Laboratory on Agricultural Technology. And thanks for your attention.
In Nepal poses a serious threat to the many fish species, and currently there are 326 dams and different river systems of Nepal, and many of them are under the pipeline, under the construction of pipeline, and so these hydropower dams are developed rampantly across the various river systems without adequate aquatic organisms like fish. So some of them are also constructed with a kind of fish passes or fish ladder, some kind of devices, but those kind of devices are not functioning properly because they were constructed without knowing the swimming performance of that particular fish species which was present in that river and along with that specific region. So most of them which are constructed in the hydroelectric dam, they are functionless. Therefore, this study aimed to quantify and address the impact of dam on fish diversity and factor affecting the abundance and richness of fishes in Madhya River, Nepal. And for the study, my study area is Madhya River, which is located in the central part of Nepal, and it is about 68 kilometer long river. And this river is a snow-fed river originated from the Annapurna Himalayan range. And the origin of this river is the Tapuche Lake, from this, which is at the base of the Annapurna Himalayan range. And from the Tapuche Lake, this river was originated. And during my study, the fish sampling was carried out in the stretch of this river from 300 meters of sea level to 1300 meters. And a total of 11 sampling sites are present. And the sampling was carried out in the 4 different seasons: winter, spring, summer, and autumn season for the 2 years. And for the sampling purpose, the electrofishing device was used. And this electrofishing device was used of this model, Shamus Reach P2000 model. And for electrofishing purpose, the sampling was done in about 150 to 200 meters of stretch in the river bank, which either left or right, which is accessible for us. And the sampling was done in a one-way method from downstream to upstream in the 150 to 200 meters, and with the help of 2 fishermen by using the electrofishing device. And here we can see that this is the electrofishing device, and this is the battery using the electrofishing device, and this is the process of electrofishing. And after electrofishing, the specimens were collected and the morphometric address were measured as shown in the figure. And after doing the electrofishing, during my survey, I found a total of 26 species, and these 26 species were recorded in 4 different seasons from December 21 to September 23, and the total number of individuals were 1271, which were across the 26 species, 17 genera, 7 families, and 4 orders. And among these 1271 individuals, the dominant order was Hyperniforms, and which contributes 76.92%, and this is followed by Siluriforms contributing 15.38%, and with Enaventiforms and Symbiontiforms each contributing only 3.85%. And among those 1271 individuals, the highest relative abundance was found in Schizophorus plagiostomos, followed by Gara lesoringus, and Barilius bendalensis, Gara gotila, and Paracanthopodia as their percentage was shown. And the 4 species had low relative abundance, which is below 5%, and while 17 species had less than 1%. And this figure shows the number of species in each family occurring in 4 different seasons in Madhya River, Nepal. And from this bar diagram, we clearly see that the Cypriniforms or Cyprinidae family is dominant in all 4 seasons, either in winter, spring, summer, or in all 4 seasons. And this figure shows the comparison of relative diversity indices of different seasons. And by comparing the different diversity indices like Simpson diversity index, Shannon diversity index, evenness, and Margallic richness, we found highest Simpson diversity in winter season. Likewise, Shannon diversity was also found highest in winter season, and the Simpson diversity was lowest in autumn. Similarly, the Shannon diversity was lowest in spring, and while the Margallic richness was found highest in spring, and similarly the evenness was found highest in spring, and Margallic richness was found highest in summer season. And after calculating those diversity indices, we done GLMM, Generalized Linear Books Model, to find out the factors affecting the abundance and richness of fishes. And from this we found that the temperature, with the increase of temperature, the fish abundance was also increased. But similarly, just opposite result was shown in the pears, That means that with the increase of years, the fish abundance was decreased. Likewise, those values which are found significant or which affect significantly on the fish abundance are shown in the bold. And similarly, the factors which were affecting the fish richness was also calculated by doing the general linear mix model. And from this also we found that temperature and pH, similarly free carbon dioxide, they affect greatly on the fish richness. And the relation was shown in the table. And along with those, the water quality variables in the upstream and downstream of dam was also calculated. And for the calculation of water quality, we use the independent t-test, and we found that a significant difference was found in temperature, pH, free CO2 and total alkalinity, and but the reservoir oxygen, turbidity and nitrates had no variation between upstream and downstream. Likewise, the fish abundance and richness of the downstream and upstream sites also show significant differences. This is shown in this table, and here we found that the fish abundance and richness have significant difference. Similarly, temperature and pH also shows a significant difference in upstream and downstream of dam, but the result oxygen have no significant difference found in the upstream and downstream of dam. And by doing this research, the conclusion was found that the dominance of cypriniforms was seen in upstream and downstream also, especially the Cyanotherax Stylostomosis species, which understood that the adaptability for the prevailing condition is higher Cyanotherax Stylostomus. Similarly, the observed decline in species richness upstream of the dam indicate potential ecological disruption due to restricted fish movement and altered habitat condition, and seasonal variation in diversity indices further emphasize the influence of water temperature and diesel oxygen level on fish abundance and their richness. So the findings underscored the need for effective management strategies to mitigate the negative impact of dam on aquatic biodiversity. And so this is the main conclusion of our study. And these are the references we were cited during this study. And I would like to acknowledge my supervisor, co-supervisor, and Department of National Parks and Wildlife Conservation for providing me the permission of doing lake fishing in Mali River, and Trichandraman campus for providing me the study leave, and similarly Kano High Park and India for providing me the lake fishing devices. Thank you.
Tibet, the autonomous region of China, Bangladesh, Bhutan. Tribe locality is forbidden in Nepal. According to IUCN red list of threatened species, Paraxyloglandis bourgardi is a least concerned species. However, in Nepal, it's a rare and conservation dependent species. Information on the feeding biology of bourgardi is highly limited. AIDS in 1987 reported general food of bourgardi, and our study reports specific foods and various aspects of feeding biology of bourgardi. We collected specimens from 3 sample sites as shown in the figure. The Maina Khola project, Sapul, Forbin, and the Bhatte Khola, Sindhupacho. We collected a total of 60 specimens ranging from 41 millimeter to 89 millimeter size. The alimentary canal was dissected from the right side of the fish. Body length, the intestinal length, and the height of caudal fin were measured using digital vernier calipers. The gill rakers, pharyngeal teeth were observed under stereo microscope, and the histology of stomach was observed under a triangular microscope. The qualitative analysis for diet analysis, we we absorbed the diet content under a stereoscope microscope, and the prey were identified up to the genetic level. For quantitative analysis, we calculated frequency of occurrence, percentage number of abundance, percentage weight, and index of relative importance. The intestinal coefficient was also calculated, as it provides information about the nature of feed. The intestinal coefficient less than 1 shows carnivorous nature, and so on. Feeding intensity was calculated based on vacuity index and gastrosomatic index. Vacuity index less than 20, as shown on the slide. Vacuity index less than 20 shows high appetite for feeding. Caudal fin aspect ratio was also calculated, as it provides nature about the swimming, about the movement of fish during feeding. Trophic niche breadth was calculated, as it provides information about the level of dietary specialization. As shown in the slide, based on trophic niche breadth, the low level, intermediate level, and high level of dietary specialization. The non-significant was converted into significant index, okay, for better comparison. Trophic level was also estimated for Forgati based on the trophic level of the prey item, plus 1. Results and discussion. Based on the diet analysis, the Forgati fed exclusively on aquatic insect larvae under 7 genera and 4 orders: Ephemeroptera, Lycoptera, Trichoptera, and Diptera. Among the insect prey, the Betis, Hydrocycid, and Neocorva have highest index of relative importance. The vacuity index was less than 20. That showed a high appetite for feeding. And the trophic niche breadth 0.56 means the Forgati had intermediate level of dietary specialization. Trophic level was 3.32, and caudal fin aspect ratio was low, 1.58. That showed high manual variability during feeding. The intestinal coefficient was less than 1. That showed carnivorous nature of Forgati, and the intestinal coefficient and standard length showed a great, a strong and positive correlation. Gastrosomatic index was high for specimens 75 mm and above, showing high feeding intensity in larger specimens. The alimentary canal is more or less S-shaped. The intestine is straight, short. The stomach is large, and there is no any intestinal data. The histology of stomach showed a presence of gastric glands only in the cardiac stomach. And this is a feature of carnivorous fish. In the leaves, there are epidermal papillae supposed to contain taste buds, and in both those jaws, there are pointed homodont teeth. There are gill rakers in all the gill arches 1 to 5, and gill rakers in the first and second gill arch are larger than those in other gill arches. And the pharyngeal teeth are also present, and they are they are approximately half the size of the oral teeth. Now we come to conclusion. The data shows carnivorous nature of Paracheloglandis burghardi, feeding exclusively on aquatic insect larvae belonging to orders Ephemera, Lepidoptera, Trichoptera, and Diptera. The burghardi has intermediate level of dietary specialization and high feeding intensity in specimens above 75 mm and above shows seems to be related to their body size and to reflect post-spawning feeding. Thank you.
Poultry, resilience to environmental changes. So, in Nepal, we are reaching aquatic diversity. Currently, based on listed, there are 252 species available in Nepal, and out of them, 236 are native and 16 are exotics. And that belongs to 15 orders and 41 families, according to Session 2019. The objective of the study is a part of the aerial conservation project which is running in Chittagong. This study was done to carry out this, and it was supported by Himalayan Nature. And the aim of this study was to assess the diversity in the Narayan and the Rapid River, because the Arial is one of the icon and highly endangered isolated state reptiles, and if feed entirely fish, and if fish is not here, this reptile species will not survive. And we have also mugger crocodile in this river, and these are the more attracts of the tourists. And so time to time assessment of fish diversity, richness is important in order to find out their survival, growth and development. So the limitation of this study, and the study was conducted during only one season. It didn't cover the entire stage of the river. As the research, it was a part of the career conservation project. The study primarily focused on understanding the local situation and identifying species in the area. So consequently, the findings don't fully reflect the complete diversity status of these rivers. So the area, as I have already mentioned, the Narayan is rapid rivers, and in case of Narayan River, which is glacier fed, part of the Gangetic basins, and also known as Gandam River. So it drains 35,000 square kilometers and runs for 322 kilometers in Nepal before becoming Gandam River. And it is from Kaligandaki and Trishuli at Devghat. When both the river meet together at Devghat, they become Narayan. habitat, it is the habitat of so many fish species. And likewise, the Rapti River, it is located in eastern part of districts and originated from the Shivani Range. So many tributaries mixed with this, and then from Etoda to it run from Etoda to Doon, and ultimately mixed in Golaghat to the Nile River. And for the study, there were 3 sites in these rivers. They were already given to us by the organizer. And in case of Rapti River, R1, R2, R3, like the Lothar, Pasara, and the Golaghat. Likewise, in Narani, Deva, Nangat, and the Golaghat was. So the survey details, I highlight about the survey details. The survey period was 29th July to 15th August 2021. The sampling here was Kashmir, and water quality was assessed by water quality grids. The sampling site, I have already mentioned 6 sites were there, R1, R2, R3 in case of Rapti River, and the N1, N2, and N3 in Narayan River. And the fish identification was done based on the Chester 2019 and Jairam 1999, and they were identified in the Central Geological Lab Kathmandu 54. So the diversity indices, this formula was used to find out the diversity indices, richness, and so the diversity indices is a mathematical measurement of species diversity in a given community based on species richness and species abundance. The summary of the species study is here. So altogether there were 7 orders, 13 families, 21 genera, and the distributions, the species distribution was in case of Rapti River, there are 18 species we found over here, and in Narayan River there were only 10 species. It was rainy season, and there was raining when we were taking the samples. Order-wise distribution and domination, as you can see over the picture. So Sabinitis was the dominant order, that is almost over 37%, followed by Sidoniforms, that was 33, or just over 33. Similarly, family-wise distribution and domination you can see over here. So Sabinity and Danielity were almost the same. So Bagrinity and Sissurity was just over the 23%. So most frequent species, that was Captivio Zaya. So now I'll move on this slide. Number of fish per square meter, it is quite important because natural water fisheries we harvest, we collect based on the national data 21,000 metric tons. It is reported since from the very beginning, and it is quite important how much fish are available in per square kilometer or per 100 square meters. That is important because without these information we can't collect national data. So this type of information is support definitely to assess, further assess the data. That's why we can give the accurate information to the nation. So in case of Kasara, the number of fish per square meter is mentioned over there. Rapti River, Lothar side 2.81, and Kasara 11.26, and Golaghat it is 7.74. Similarly, in Nangat it was 4.90, near to 5. Golaghat is 11.3, and Golaghat 6.3. So, based on these information, Kasara, that is R2 in Rapti River, shows the highest density of fish per 100 square meter, yet that is 11.26. This indicates the most abundant fish population among the listed sites. So habitat suitability, I think we just consider habitat suitability and resource availability may contribute this high fish count in our
species worldwide. And in context of Nepal, in research paper that reported by Special 2019, there are 252 freshwater species in Nepal, which lies on the 15 order, 25 and 120 genera. In context of Ocean River Basin, Kappa 2008 found 92 species. Limbo and Supa reported 81 species. Guru Ika 2016 reported 125 native and 7 exotic species. Up to 200 species might exist, highlighting the need for comprehensive studies from this review of these two papers. The possible fruit plain and tributaries of an essential spawning ground for many freshwater fish species due to their diverse habitat and water quality. And these habitats in most people are set by water quality, surface rate, distance, and hydrology, creating microhabitats for various life species. Juveniles are favored shallow vegetated areas, while adults prefer deeper pastoral water. Freshwater fish in particular have diverse types, including invertebrates, algae, and smaller fishes, which are vital for their health. The different rich water support strong for wind wave, and that is essential for the ecological balance of river. And the general objective of this study is to explain physiology in the horizontal conservation area, and the specific objectives are diversity and abundance in Kamakosi and Singati rivers within the horizontal conservation area, and with study of water quality parameters of Kamakosi and Singati area, and identifying the spawning, breeding, and nursery ground in the Kamakosi and Singati rivers within the horizontal conservation area. And the significance of the study, as it is a sub-study of the project of horizontal conservation area, this study has successfully assessed the significance in the ethanol diversity and water quality of the Kamakosi and Singati research. And this is documented the fish species present, observed seasonal variation, and detailed their distribution and ecological habits. And the findings will add the restoration of declining fish population and promote socio-economic benefits through sustainable fisheries and ecotourism. Furthermore, the study enhances global biodiversity knowledge and supports climate change research and waste conservation awareness. For this, the study was conducted in two rivers, Kamakosi and Singati, and it covers the 27 km stretch of the Singati River to Kamakosi Confluence in Kamakosi River, and we work in 9 sampling stations with Susan that is based on the river accessibility, habitat, heterogeneity, and comprehensive in the alignment of the study objectives. Of that, in Singati River, we selected 4 stations and remaining 5 stations were in Kamakosi River. And this is this table describes detail of the stations name, and there are 7 stations, and latitude, longitude, altitude, and the type of the river bed. The sample was for sample collection. The sample was collected from October 2023 to March 2024, covering the seasons, pre-monsoon, winter, and post-monsoon. For this, local fishermen will hire by using the cast net of 5 and macro mesh size, and 20 sampling takes 4 stations, and the survey for 2 hours covering 500 meters upstream and downstream from the sampling station. Each survey contains a total of 10 days of the report. The fish species were counted, reserved in form apiaries and other breeding factor investigation, documented the names, habitats, preferences, spawning ground and periods, and behavior with fishermen and guidebooks. And the fishes are some fishes are processed from the local market for study. The species were identified in the Central Department of Zoology Museum and identified to 1981, 1990, 2019, 1981, and the recent taxonomy papers. And the materials for the water quality pH was measured by pH meter, DO was measured by DO meter, and TDS casting, and these are the materials. And for water parameter, temperature, velocity, TDS, pH, DO, and hardness, DO were measured by related meters, meter, TDS meter, pH meter, thermometer, etc. And while the total hardness was measured by practitioner method by using EDT method. And for diversity statistical indices, we analyzed the diversity indices. For that, species diversity indices and below species diversity indices, richness index, and evenness index were used. And we also conduct a multivariate analysis to analyze the species diversity between species diversity and environmental variables by using the data parameter using R. Result and discussion. During the study, 7 species were reported during the study time period. The ICAF conservation status was found of that 5 species were under vulnerable and 2 species least concern. And this table shows the station-wise species diversity. In that, the we found only 2 orders, Cypriniformis and Pseudoformis, where the dominant order is Cypriniformis with 91% and Pseudoformis 29%. And the Cypriniformis constitute 6 species, followed by Pseudoformis with 1 species. And the family-wise composition shows that Cyprinity is dominant, followed by Pseudoformis and Pseudoformis with 1 species. A total of 536 individuals species were recorded during the study period. Among the 40 species, there are Cypriniformis 60%, Pseudoformis 31%, and Pseudoformis 9%. And the result also similar to the year of 2017. At that time, 2015, when we were working on positive work, the data also reduced in our study. And the diversity index, the highest sample diversity index was found at station 9. That means that the station was more derived and balanced ecosystem, while the lower value found at station 5 indicates the less diversity and potentially and imbalance that may be. And maximum marvelous richness was found at station 4, 8, and 9. That includes a large number of species related to the total number of fish, while minimum at station 3, 5, 6, and 7 that indicating pure different species related to the total number of the fish. And the evenness index was found highest in station 9. That means the species are most evenly distributed, and with this species, and station 5 has the least evenly distributed species. And the water quality analysis correlation with fish diversity and water quality remains in the RV plot. The certain fish species such as Isosceles, Progastus, Sironacus, Sebaceous, and Neuropisophytes demonstrated the association with temperature, velocity, and hardness. Garapotella, Sagittarius, Sagittarius are positively related to the water disorption and negative to hardness. Similarly, occurrence of Sironacus, Sebaceous is highly associated with hardness and negative to disorption. And we also conducted the spawning and breeding nursery ground by the observation method and CS locality. We found the station near 3, 5, 6, and 8 are potential spawning grounds of the Singalese and Tarapus river. And this is the detail of the spawning and breeding ground. And conclusion, the species we found only 7 species till now. And up to that, 5 are vulnerable this follows the methods and environment. We are very grateful to NTMC ICAF project for providing budget funding for this study, and we are very grateful to Mr. Gopal because the local fishermen will be assisting with the existing fish collection throughout the study period, and also acknowledge to the people who directly or indirectly contributed to this. These are our references. Thank you.
And the public pond is no longer used in many places. That's why the public systems or public mechanism is more effective to survive. And even we ask the first community settlements was established in Rara. And there is one big pond. And we ask the community what the mayor, the municipal chairperson, they agreed to commercialize this pond. And they said, rather than conserving as a community aquaculture land, it's better to give as a loan for certain period, and they can take the money. We do not convince them. The convincing to the community is very challenging, but comparing with the private, it's easy to conserve in the public. We initiated for the private as a household aquaculture land. It started from the Kaspi, where the Rupa lake is completely restored. This is the good achievement equity as for last 2 years. And we started from there, and now the community, they are also agreeing to establish, they call it community aquaculture in Kaspi. Probably next year, we will have this community aquaculture. Rara Lake is a...
I want to clarify. That is not silent residences. I think put the correct residences. Maybe Rara is I know there is a Rara Lake. That is not silent residences.
The fish species in this community in a pond. And we can keep the fish there for a longer time. But to conserve, I think, will not be possible biologically because the fish have two different atmospheres. To survive, they can survive in a pond, that's all right. But to breed, to propagate, they need some different type of environment. They need some kind of water, they need some different environment to cool oxygen, and they need to run up and down and migration. So in this way, if you just keep fish in a pond, they can stay there till they die, but it will be very difficult for them to keep on their generation. For example, common carp you can do. If you put sahar cannot breed in a pond. I mean, if you put some other species, they can breed the pond. So they need their special requirements for their breeding and spawning and surviving. So I don't know how practical it will be.
First, we should know the habitat of the fish and any other species, what environment they live. Here I use the terms aquaculture. It means not only the public pond or within standing water. It means even it can be defined in the flowing water. Even Narayani River, we can define certain area as aquaculture. The principle is naturally let them interact and let them evolve themselves. We completely arrested the evolution process. That's why we got a problem. This is one of the main reasons. That's why we want to speed up the evolution process, and there are different mechanisms. All of these mechanisms are aquaculture. As you pointed, first we should know the habit, what environment they like, what they want. First we have to identify, otherwise it's not possible. I am not a fish expert. We consult all the fish experts. And across the country, even we discuss with the national park personnel, wetland personnel, and we also NTNC teams. And they have been wherever possible, let's start. That's the strategy we are following. And we specifically we should know what environment there. So there is a big gap. And this, I think the researchers should work on that. After identifying the habitat, and we can start on that. Thanks.
We do it in Narayan.
I had the opportunity to listen to your presentation, and it was really excellent. Maybe some sort of suggestion I would like to have. First is that I also calculated the area of the national parks you mentioned, that there is conservation would be conservation of the different species would be, and that is 25% of the country area. So it is quite a huge place, but I would have a recommendation, but starting a bit behind. Is that, for example, there is GAF, is Global Environment Fund, and they are very much interested, for example, the conservation of fishes. And we used to have a few years ago a GAF program in Kyrgyzstan, for example, in this city. And what I want to suggest is that to make a cooperation, not only but all you scientists together sit down and make a concept paper and go after the funding, because as I understood, not only in Nepal but all over the world, the biggest problem is that, okay, we have idea, but who is financing the whole work? And therefore, but today, even I have an experience, long experience, that organizations, international organizations are extremely happy if they receive something feasible, nice program to finance. Sometimes the problem is that they have money, especially at the end of the year, but they cannot spend because there is no good idea to spend. So therefore, sometimes you also experience that there are programs which are for nothing. It is just running somewhere in the world, but no benefit. So that please think about this is one. And the other thing is that you mentioned temple ponds. Again, that when you make a proposal for conservation, because it sounds a very good idea, because the first time many of the species were kept only in these temple ponds and were respected by people, so that no poaching, no problem. That to make a countrywide survey that which type of temple ponds you are having, that you can say exactly that this is an area of so many hectares, so many in number of ponds, and there are cold water, warm water, different ponds, and then how this could be used, for which species could be used this, and survey also the area of to have a suggestion for the financiers that what is the benefit of the different national parks, which type of fish you could conserve there, and at last, that if you involve what Professor also discussed yesterday at the dinner, is that an active participation of the fishers community, because they know exactly the things, and then if they approach on a good way and they trust on you, they will get all the information, otherwise we get never, because we are not going there fishing every day, but they do, so that they know exactly how is the fish farm. So these are
Thank you for the resources. Thank you for the resources.
You know,
There are many jeep pools are existing in Nepal. I had an opportunity to work as an expert in the what EIA, environmental impact assessment of the water supply, Melanchi water supply. Okay, few years back. That time we went to Melanchi, and there is a place Timbu, and above Timbu there is one place Sarthali. Yeah, and that place, when you have one time only the casting you use, you will have 3-4 kilos of this cyclopharex, ocelot fish. So exciting, And that was the only one place where we can get so many species of ocelot, that is cyclopharex. Yeah, so it is naturally protected because it is very difficult to reach that place, and the common people not reachable. So we should survey this type of places in Jaipur. We have in the Chikali also. Now, last time I have mentioned in one I have a popular article written in this magazine last time in Sunila Madam requested me for a very popular article. Whatever experiences I have gained so far in this academic life, I have given all the things here I have noticed. So I would like to request all the participants to go through. At least I will be very happy if you give me any comments, in this. I have all my experience, past, present, and what will be the future of the fisheries of Nepal. Yeah, that I have noted in this, which is unfortunately in Nepali because it's a very popular article for all the levels of the fishery concerned people. Okay, so in the Chikali also there is a pond, and it is Sisnaran, the Sisnaran area, and I have started the first sentence in this paper that in the last New Year, the first New Year day, I went there, and I had that imagination that when I used to take my students from the River University to that place, and was so to be happy, that all these cyclopharex species were there, swimming and, like that. And that was naturally protected. But that day when I went there, I had in my mind the same scenario. But when I went and saw the things, everything gone, vanished. There were all the other cars, the decorated fish, aquarium fish like that. Why? Because that pond was open for all the people, especially for the religious people. When they leave the fry and finger means they are from the religious point of view. And in this way, now there is no asala, no cyclopharex species, but only all the colorful fishes, like koi, like that. So these are the places everywhere in Nepal. We have to find out these places and preserve it for as gene pool for conservation of biodiversity. My aim, my dream always is that let us make our Nepal as a living aquarium. Let us expose it for the other world people. Let them come and see it, not in our book. After many years, they will say, in this book, this fish, this species, but where now? So this is not going to be the case like the dinosaurs is, just we see in the diagram in the book. So my request to all the young generation, please save our fish species, which are very, very uncommon, very, very new to Nepal. Still, there are many works we have to do, for the fisheries of Nepal. Very initiative, very work we are doing. But one thing we should keep in our mind, Let us not enjoy with the exotic fish. No more propagation, please, with our endemic species. Can you imagine? There are 16 species here, which are the endemic species of Nepal. You cannot find those species even in our in India, where our water flows, from Nepal to India. We don't find. There are 16 species and we don't care. We have no patent right also even for those species. When, please, our young scientists, be concerned with these things, Thank you very much for your vision, my views, my dream. Thank you very much. So, let us proceed. Yes.
Thank you, ma'am, for explaining sensory. So we also plan to have a conference program over there. And regarding
I wanted in my conclusion that every ladder or every fish species will be prepared by properly knowing the swimming performance and the behavior of the fish species which are particularly present in that area. So I just recommending for that.
Which is our Amatya? Yes. Feeding biology of plants. This was before known as Goragati. Okay. Then it was Econoclanis Goragati. Now we have mentioned his generic name, legal name. So how it come? From where you have taken? This is my inquiry as a taxonomist. Thank you very much.
This main feature, the name, I think the name says.
Good luck for your
Thank you, madam. Thank you.
40 species, 166 species are under the ICAF, and there are 4 species. And this map shows the distribution map of the small indigenous species. This is by removed from all data. And the ocean river system. Ocean river system harvests 100 to 120 SIS species. Similarly, Korali also 100 to 128 species. And 0 to 6, the small rivers have 0 to 16 SIS species. And my study area was in Lumini province, covering the 3 rivers and 2 lakes, Banana River and Jagdishpur Reservoir in Kapilvastu district, Daman River and Gajari Lake in Punjab district, and Arukola in Naharparasin district. And the study was conducted from 2018 to 2021, covering 3 seasons, post-monsoon, pre-monsoon and winter. And the results, 52 species, over 770 families and 44 genera are reported from that study area. In that, Gajari had 32 species, Jagdishpur had 34 species, Dano River has 28 species, Banana River has 14 species, and Arukola has 20 species. And the fish population of Gajari Lake that is dominated by Cyprian population 56%. And the least species reported by this possible Hungary and Belgian forest. With Belgian forest, with only one species, the Netherlands Pensicola, and Hungary forest with one species, Scalable Cascasic. And Jagdishpur Reservoir, here similarly also Cyprian forest is a major dominant species, like that in Dano River. Here also Cyprian forest is a major order in Bangona as same and Arukola as same. And in review of the Nepalese river forest, the Cyprian forest and order Cyprianity is a dominant order and family of Nepal. And in the north, the Cyprian forest and family Cyprianity have about 23 species, the dominant order and family of 4 study area, followed by the second number in 9 study area, Bali is in second number, Metasimility is third followed by number of species 4, immaturity, number of species 3, ambassador, number of species 2, sanity 2, hospitality 2, and sessury number of 2. And this table shows the different number of species according to the order-wise species in study area. And this is a family-wise scenario of this SIS. In family also, we saw the security is the highest family that's followed by variability, marginality, and motility. Like species are there, you found species are in my study area in nativity, only one species native in geographical reservoir, motility varies in geographical reservoir. And the species population was varied according to locality. Like rivers were dominated by Gara species, that's commonly called as Buduna, beverage species commonly called Ogala, and bark species like Rasmula Dani, like some barks species. Whereas the lakes were dominated by Amphipteraphola, Isomos, barks, and minnows. And the upper region of rivers were dominated by loaches and succulent fishes. I found in my river in upper region, all upper regions are dominated by Gara species and loaches, and in some area succulent fishes also. The middle region was dominated by barks and minnows, and the lower region of study areas were occupied by warm water fish. And I did a work on the SIS, and here I not mention the species that are not fall under the SIS, like labio species, tori species, sagittarius species, not mentioned here because they are not fall under the SIS, but all species are found in my study area, especially in rivers, not in lakes. My result was also considered similar with the Thai 2006, HC 2002, Sarma and Smith 2001, Patri 2020. They also found a similar type of dominancy in the rivers of Western Nepal in Vedi, Kaligandagi, Rapti river.
Stalls due to the session break, and those who have poster presentation, please paste your poster in the frame. Next presentation is on spatial distribution, abundance and diversity of zooplankton in transboundary rivers of Bangladesh. The presenter is Mohammad Mainuddin Pashan.
It was calibrated and length was measured and longitudinal part was made and serial number was separated and preserved in 5% formalin. The government preserved in kissing water and mounting was done in centrifugal and observed under microscope. And here is the calibration, frequency of occurrence, volume of lichens, and index of preponderant agents. In result, high number of tilapia was 75% full, while high number of Tazanama was 50% full. These are the diagrams of pregnancy. Complete genera were recorded and 2 genera of zooplankton were recorded. Food items presenting cut of coricolis neoticus. 23 genera of phytoplankton was recorded. With zooplankton, 7 genera, nematodes, hatchling, fish parts, and cell particles and predators. And in Chandanama, phytoplankton 8 genera were found, and 4 genera of zooplankton were found, and insect, and along with fish scales. And this is the fish parts that was collected from the god of coricolis neoticus. These are the hatchlings and small fish. Government analysis of coricolis neoticus shows that they feed on high number of phytoplankton. Among them, Pachycetus is the most food eaten by tilapia, and along with zooplankton and predators and other parts is found small. Government analysis of Chandanama, they feed mostly on microcrustaceans, zooplankton, insects, scales too, and phytoplankton are found occasionally. And in discussion, stomach content analysis of omnivorous in nature. Researchers suggest that polygamous individuals to be omnivore, where another researcher reported it as herbivore. Our studies show that based on frequency of occurrence and volumetric contribution, phytoplankton was most dominant food in polygamous individuals, which is similar to finding of these researchers. The present study has shown the lot of Sandanana contain majority of the items in animal origin, suggesting it to be carnivore in nature. The present findings were supported by findings of researchers and Sandanana to be highly carnivorous as well as competitive scale figure. And in conclusion, polygamous individuals is omnivore, whereas Sandanana is carnivore as well as competitive scale figure. And diversity inheritance and adaptability is found in polygamous individuals. And long-term competition has been seen with other native species for food as well as habitat, making indigenous species more vulnerable to predation. Parents has been reported to have pointed genera of phytoplankton and dual genera of zooplankton, and Sandanana is genera of phytoplankton and both genera of zooplankton. And escape-free habitat of Sandanana have left native species less, making more susceptible to various kind of diseases in other native species. So, laws should be implemented against such kind of invasive species to introduce in such kind of things. And I like to acknowledge lack of funding, research and late authorities and other agreements. There are some references